This is question number 1 of exercise 5.4 from the chapter Continuity and Differentiability. The question is differentiate with respect to x e to the power of x upon sine x. So we assume that the given function is equal to y, and on differentiating I'm going to get dy by dx is equal to dy dx of e to the power of x upon sine x. Okay, so you can see that this function is in the form of quotient of two functions, that is it is in the form of a function divided by the other. So we are going to apply the quotient rule, and we can write dy by dx as equal to the denominator into the differentiation of numerator minus numerator into differentiation of denominator upon the square of denominator. Okay, so d by dx of e to the power of x is e to the power of x, d by dx of sine x is equal to cos x. So this would be equal to sine x into e to the power of x minus e to the power of x into cos x upon sine x whole square. So this can be written as e to the power of x into sine x minus cos x upon sine square x. Here one thing is to be noted that dy by dx is only defined if the denominator is unequal to 0. So this is only possible when x is unequal to n pi, where n belongs to integer. So this would be the required answer. This is question number 2 of exercise 5.4 from the chapter Continuity and Differentiability. The question is differentiate with respect to x e raised to the power of sine inverse x. Now to solve this question, first of all, we are going to solve this question by chain rule. So first of all, we read the question. So it is going to be read like this: e raised to the power of sine inverse of x. So first of all, we are going to differentiate e and then sine inverse of x. Okay, so to apply the chain rule, first of all, we assume that d by dx of sine inverse x is same as d by dx of e to the power of x. So differentiation of e to the power of x is e to the power of x. So differentiation of sine inverse x would be equal to e to the power of sine inverse x. And because we are differentiating here not e to the power of x, e to the power of sine inverse x, so we are going to multiply this with d by dx of sine inverse x. Now d by dx of sine inverse x is equal to 1 upon square root of 1 minus x square. So this would be equal to e to the power of sine inverse x upon square root of 1 minus x square, or this can be written like this also. And here it should be noted that because we have been given e to the power of sine inverse x, and secondly the value inside the square root is 1 minus x square, so x is going to belong to the open interval minus 1 to 1. That is, in this interval this expression or dy by dx or d by dx of e to the power of sine inverse x is only valid. Okay, so this is my required answer. This is question number 3 of exercise 5.4 from the chapter Continuity and Differentiability. The question is differentiate with respect to x e to the power of x cube. So we assume that y is equal to e to the power of x cube. So dy by dx is equal to d by dx of e to the power of x cube. We are going to apply chain rule to differentiate it. So first of all, we are going to differentiate e to the power of x cube by assuming x cube as equal to x. So differentiation of e to the power of x cube would be equal to e to the power of x cube into d by dx of x cube, like this. Okay, and differentiation of x cube is equal to 3x square. So I'm going to get dy by dx is equal to e to the power of x cube into 3x square, or 3x square into e to the power of x cube, which is the required answer. So in this manner I'm going to differentiate e to the power of x cube. This is question number 4 of exercise 5.4 from the chapter Continuity and Differentiability. The question is differentiate with respect to x sine of tan inverse of e to the power of minus x. Okay, now to solve this question, we assume the given function as equal to y, and to make a point, when we read the given function, it is like this: it is sine of tan inverse of e to the power of minus x. So this means that first we are going to differentiate sine, then tan inverse, and then e to the power of minus x. Okay, so in this order the differentiation should be done if we are going to apply the chain rule. So therefore dy by dx is equal to d by dx of sine of tan inverse of e to the power of minus x. Now d by dx of sine x is equal to cos x. So because differentiation of sine x was equal to cos x, but here since we were differentiating sine of tan inverse of e to the power of minus x, so d by dx of sine of tan inverse of e to the power of minus x would be equal to cos of tan inverse of e to the power of minus x into d by dx of tan inverse of e to the power of minus x. Further, d by dx of tan inverse x is equal to 1 upon 1 plus x square. So this would give me this term as it is, 1 upon 1 plus e to the power of minus x whole square into d by dx of e to the power of minus x, because we are differentiating tan inverse of e to the power of minus x. And further differentiation of e to the power of minus x is equal to e to the power of minus x into d by dx of minus x. Okay, so I'm going to get this term as it is. This term I've written as 1 upon 1 plus e to the power of minus 2x. I've simplified this whole square, and d by dx of e to the power of minus x is e to the power of minus x into d by dx of minus x. Okay, and differentiation of minus x with respect to x would give me minus 1. So this would be my required answer, e to the power of minus x cos of tan inverse of e to the power of minus x upon 1 plus e to the power of minus 2x, which is the required answer. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.